All right, this is problem 6 of the 2022 MMATHS Individual Round. The problem reads, Siva has the following expression, which is missing operations. 1/2, blank, 1/4, blank, 1/8, blank, 1/16, blank, 1/32. For each blank, he flips a fair coin. If it comes up heads, he fills it with a plus. And if it comes up tails, he fills it with a minus. Afterwards, he computes the value of the expression. He then repeats the entire process with a new set of coin flips and operations. If the probability that the positive difference between his computed values is greater than 1/2 and can be expressed as a over b for relatively prime integers a and b, then find a plus b. All right, so we have this expression 1/2, 1/4, 1/8, 1/16, 1/32, and we want to do something with it, okay? So we have, let's say we have two numbers, let's call them x and y, and each of them is, let's see, 1/2 blank, 1/4 blank, 1/8 blank, 1/16 blank, 1/32. And we're given that we want to find the probability that the positive difference between the two computed values is greater than 1/2. For example, if x is like plus, plus, minus, minus, and y is minus, plus, minus, plus, then you get x is equal to 1/2 plus a fourth plus an eighth minus 1/16 minus 1/32. So if we write this over a common denominator of 32, we get 16 plus 8 plus 4 minus 2 minus 1, which is 25. And y would be 1/2 minus 1/4 plus 1/8 minus 1/16 plus 1/32, which is equal to over 32. This is 11. And their difference, turns out that their difference, positive difference, is 14 over 32, which is less than 1/2. All right, so that's sort of an example of what we mean when we say Siva is flipping the fair coin. We want to find the probability that the positive difference between his computed values is greater than 1/2. And my first claim is going to be that for x and y, the sign on the 1/4, that is this sign, they have to be different. And why is this the case? Because, well, okay, first of all, let's assume that they're the same. So x and y have the same sign. Like they could both be plus, they could both be minus. Whatever. But in this scenario, what is the greatest possible positive difference between them? Well, the greatest possible positive difference is if the number is 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. And the other number is 1/2. We specified this as a positive sign. And then we have to subtract the other three in order to make the two numbers as different as possible. This guy is equal to 31/32. And this guy is equal to 17/32. And so therefore the greatest positive difference you could possibly make if they're the same sign is 14/32. You can see that a similar thing will happen if you make them both minuses or whatever. This is less than 1/2, which means that if these two signs are the same, then you're never going to get a positive difference greater than 1/2, which is what we wanted. Okay, so in order for the positive difference to be greater than 1/2, our first condition that we need to meet is that the two signs of in front of the 1/4 have to be different. So one of them is going to be a plus and one of them is going to be a minus. And this will happen with probability 1/2. Because no matter what the sign is for x, there's one out of two possible signs for y, either a plus or a minus. So now that we have that, that's our first condition, but that's not all we need to do. We still need to ensure that these remaining guys, that is the 1/8, the 1/16, and the 1/32, behave nicely. Okay. So let's see. So without loss of generality, we let x's sign be positive for the 1/4. And we care about these guys, and in particular, if we were to take the positive difference between x and y, it would be x minus y, just because of the positive 1/4 and the negative 1/4 making x bigger than y. So what do we really see is that if you take x minus y and x is 1/2 plus 1/4 plus stuff, and y is 1/2 minus 1/4 plus stuff two different stuffs. This is going to be equal to 1/2 minus 1/2 plus 1/4 minus negative 1/4. So this is a half plus stuff minus stuff two. We want this to be greater than 1/2, which means that stuff minus stuff two has to be greater than 0. And in particular, this stuff is going to be the 1/8, 1/16, and 1/32 term for x, and stuff two is going to be that term for y. So in essence, all we need is this guy to be bigger for x than for y. And what's the probability that that happens? Well, the stuff for x can be either be bigger, less than, or equal to the stuff for y. So blank 1/8, blank 1/16, blank 1/32. Either greater for x than for y than for x, or equal to each other. Okay, first of all, let me calculate the probability that the stuff, these three terms, is equal for both x and for y. And actually, the answer turns out, I claim the probability for this case is 1/8. And the reason is because no matter what we choose for x, like let's say minus plus minus, the probability that these three guys are all the same for y is 1/2 for this one, 1/2 for this one, and 1/2 for this one. There's only one way to choose a sign for each of these three holes for y such that the sign is equal to the one for x. So if the stuff is equal for x and for y, that happens with probability 1/8. Now, what's the probability that the stuff for x is greater than the stuff for y, these three terms? Well, my claim is that the answer is going to be half of the remaining time when they're not equal. It's the x terms are going to be bigger than the y terms, and the other half of the time the y terms are going to be bigger than the x terms. And this follows from a basic symmetry argument. If you have an arrangement where the x's terms is somehow bigger than the y's terms, like for example, if all three of these guys were minuses, well, you could easily flip these two around and nothing changes except that the x's stuff becomes smaller than the y's stuff. So by that symmetry argument, these two probabilities are the exact same. But since they have to add up to 7/8 because the other 1/8 of the time, the terms are the same for both x and for y, that means that the probability that the x's terms is bigger than y's terms is 7/16, and the same for y, 7/16. Now, what information do we gain from this? We gain that the 1/8, 1/16, and 1/32 terms have a collective sum that's bigger for x than for y, 7/16 of the time. And this is exactly what we want, because we want the x stuff minus the y stuff to be bigger than 0. So the probability that everything else after the 1/4 term checks out is 7/16. And therefore our total probability is 1/2 times 7/16, since the 1/4 term and the other three terms are independently chosen. This is 7/32, making our final answer 7 plus 32 equals to 39, which is our final answer. Thanks for watching, and I will see you next time.